Today again we are in the lesson fire alarm. Last week we did an introduction of the fire alarm and we learned why we need to have a fire alarm detectors. So today we are going to still talk about the fire alarm detectors, and we will talk about very few things, and then after that we will go to the review. The installation, we said that for you to be able to install the fire alarm detectors, the fire alarm comprises of control panels, it comprises of the sounders, it comprises of the alarms themselves. That we have the smoke detectors are there and the heat detectors. So we will learn on how to do the installation of these fire alarm detectors. So just as a review to remind ourselves so that we can be on track. Terminologies that are used in this fire alarm installation, we have something known as qualified. Qualified means a competent and capable person or company that has met the requirements and training for a given field acceptable to the authority having jurisdiction. Meaning, for you to be able to involve or to engage yourself in the fire protection field, you have to be able to be enrolled or to be a competent person, meaning you must have the experience that is needed. You must be certified by the authority. The authority must have proved that actually you can do the fire alarm protection, you know all the rules and you know all the zones, and your staff are well trained to do the work. So a qualified might also mean that a person has knowledge of the installation, construction, or operation of operators and the hazards involved. So there are a lot of hazards that are involved in the fire alarm protection. And now we go on to other terminologies. We have the device. A device here will refer to an input, because when we'll be doing the installation and when we'll be looking at the diagrams, we'll just go direct and you'll be able to know what these things mean. A device refers to input, e.g. the automatic fire detector, the manual boxes, the water flow switch, and etc. Appliances here will refer to output, e.g. the horn bell, chime, strobe, speaker, and etc. And the module here will refer to the addressable input and output, e.g. the monitor, the module, the control module, or the panels. Terms like a circuit refers to an electrical interface, e.g. the IDC, the CLC, the SLC, and the NAC. We look at all these circuits. And we'll be having zones. When we are installing the fire alarm system, they are installed in zones. So zones refer to an area which may include devices and or appliances. It is an area that may include devices or appliances. And then we have the circuit class refers to its fault tolerance or how the circuit will perform during a fault condition. The circuit class will refer to its fault tolerance or how the circuit will perform during the fault condition. That is by labeling the classes. We have the class A, class B. These are now the classes of fire. And I know you people did this classification of fires. I don't know, you did them in module 1 or you did them in the first semester, but I know you must have met them somewhere, the classes of fire. So we have the class A, class B, class C, class D, class E, or class X. And the hardware. Now the hardware here, we have the fire alarm control panel. We have the other modules. We have the remote annunciators. We have the remote power circuits and pathways. And we have the alarm control panel. So the alarm control panel here is the alarm control panel unit. We have the component of the fire alarm system. This is a component of the fire alarm system that provides the primary and secondary power sources. We said that the control panel is like the brain or the engine of the system, meaning the circuit will be installed in this in the circuit. So the fire alarm control unit, that is a panel. It is a component of fire alarm system provided by with primary and secondary power sources, which receives signals from initiating devices or other fire alarm control units. So the processes these signals to determine part or all of the required fire alarm system output functions. So we also have something, the signal. Now, what is a signal? A signal is a message indicating a condition communicated by electrical, visible, audible, wireless, and other means. So when we talked about the audible, what do we mean by audible? When we talked about the audible, this is the sound. Now, the sounders in there, the sounders that produce this sound in the system. And when we talk about the wireless, meaning it can communicate. You see, if there's a fire outbreak, the smoke detectors will detect the fire. And when they detect the fire, they'll be able to communicate to the fire alarm stations or to the fire control stations by a message. So that is now the wireless working there. And they communicate electrically because all these equipments or appliances, they use electricity. And we said for this is a class, fire alarm installation is also classified under the emergency lighting, because they use backup power. You don't use normal electricity because when there is fire, electricity has to be put off. So when it has to be put off, so we have to bring up the backup power. So it is this backup power that powers the control panel to be able to produce the information that is needed. And then we have a condition. What is a condition? It is a situation, stroke environmental state or equipment state of fire alarm or signal system. So we have the process from condition to signal to response. So when a condition occurs, maybe there's a fire breakout or there's a smoke being detected, then it sends a signal. Then from the signal, then it brings a response. So in the response, it means that the people responsible needs to respond. And we said that this fire alarm system has been incorporated in a way that it has replaced a human being. It has taken the part of a human being for being able to detect fire. So what a human being can do when detecting fire is, number one, the person can feel smoke. Another thing, the person can feel the fire or can see the fire itself. Another thing is the person can communicate by either shouting or calling people to come and rescue. So this control panel, this fire alarm circuit also acts like just the way the human being could act. So by being able to feel or to smell, you can smell smoke. So that the smoke detectors have come in to replace that sense of smell. What about the sense of seeing? They can see the fire. So we have the heat detectors. The heat detectors have come in to be able to detect fire to replace the human eye that can be able to detect this fire by seeing. And then the making the noise, meaning alerting. The human being, when the human being can be able to see the fire. When you see the fire, you have to shout for help. So that's shouting. So the fire detectors have come in with things called the sounders. The sounders, these are things that produce the sound or make the noise or alert the people or alert the company that is able to control the fire that there is a fire outbreak. So this fire alarm control panel is a very responsible system. An alarm condition. So this progress from the condition to signal to response has steps. So we have the alarm condition. Now, what is the alarm condition? It is the abnormal condition that possesses an immediate threat to life, property, or mission. So it is an abnormal condition. Like if you can see a lot of smoke, then that is an abnormal condition. Or if you can see a fire outbreak, it's an abnormal condition, and it is likely to possess immediate threat to life. Meaning, if it breaks up in large quantities, it will make sure that the property is burnt or consumed in the fire. So it is called a condition. It is a condition that is created by fire outbreak. An alarm signal. So a signal that results from the manual or automatic detection of an alarm condition. That is called the alarm signal. And we have the alarm response. Now it is the response to the recipient of the alarm signal. When the signal has been taken, and most of the time it is taken, it is made in a way, the signal is made in a way that it sounds to the environment. It sounds to the environment to alert people, and at the same time, it sends a communication directly. It sends a communication directly to sounds a communication directly to the fire station, so that it can be able to tell these people to tell the fire alarm response team that that to tell them that the fire has broken up. So we also have a supervisory condition. What is a supervisory condition? It is an abnormal condition in connection with the supervision of other systems that processes or equipment. So supervisory condition, we have said under condition, it is an abnormal condition in connection with the supervision of other systems. So supervisory signal, it is a signal that results from the detection of the supervisory condition. What about the supervisory response? It is a response to the recipient of the signal. It still follows the same procedure. We have now a trouble signal. Now, a signal that results to a detection of trouble condition. And the trouble condition is now an abnormal condition in the system due to a fault. Maybe a fault has occurred, like now electrical fault. So what brings out this is it is called a trouble condition. Then a trouble response, it is the response to the recipient of the trouble signal. So we talked about the hardware that are used. The hardware used there are now we have the network card that is used for communication, the conventional that is an addressable circuits, and we said that the fire during installation of the fire circuits, we break it into zones that called the addressable circuits, and then we have the loop adders. So that is the SLC and the graphic driver. The digital alarm communicator systems, that is the radio systems, it is not an intent of section to limit the use of listed equipment using alternate communication methods. Provided this method demonstrate performance characteristics that are equal to or superior to those technologies described in the section. So remote annotators, these are some of the components that are used in the fire alarm. So this is a control panel. You can see the fire control system. At this point, this is where control is done. It can be able to read to show any danger. In case of danger, it will read itself here. So this is the digital display of any arising problem or detection of fire. Another thing is the remote power supplies. We have the distribution power. And we said that the fire alarm or the control panel uses backup power. It does not use the normal electricity that we use. So it uses backup power. So this is the distribution power, an example of a remote power supply for the fire alarm system or the circuit. The secondary power supply, it is sized to operate the system for 24 hours. So in the non-alarm condition and then for 5 to 15 minutes in the alarm condition. So it can operate for 15 hours on an alarm condition, meaning when the alarm is not on. And it can operate for 5 to 15 minutes when the alarm condition is on. That is emergency voice alarm. So the condition system for 15 minutes at full load when it's now giving an alert or an alarm. We also have the battery set size calculation now. The process when you want to calculate the batteries that you want to use in the system. That is, step one is to get the total quotient, that is an alarm load times 24 hours plus. Now, when there is no alarm, another one is to get the total alarm load times, that is 5 to 15 minutes for the EVA systems plus, and then the next step is a 20% safety margin. There has to be a safety margin for that. Circuits and pathways. Now the pathways are class designations. The pathways shall be designated as a classes A, classes B, classes C, D, E, and X, depending on their performance. I said when we are doing this wiring, we normally group them into classes. So alarm supervisory trouble. Now this is the fire alarm control. For class B, initiating device, circuit, alarm, and trouble condition. You can see how the class B look like. Class A, initiating device. This is now initiating device for the trouble condition. You can see how it will look like. You will see the difference between class B and class A. Then all devices, that is the compatibility. All devices and appliances that receive their power from the initiating device circuit for from the initiating device circuit or signaling line circuit to a control unit shall be listed for use with the control unit. So this requirement does not apply to notification appliances and circuits. Addressable devices. What are the addressable devices? A fire alarm system component with a discrete identification that can have its status individually identified or that is used to individually control other functions. So devices are pulled and changes in condition are reported, alarms supervisory and trouble. The SLC supervision, now this is the addressable fire alarm control panel. That is the signaling line circuit. That is the meaning of the SLC. So you can see how they are located, how they are installed in different places. Now these are the sounders and the smoke detectors embedded in the sounders and the way they are put or they are installed. Analog initiating device, that is the sensor. An initiating device that transmits a signal indicating varying degrees of conditions as contrasted with the conventional initiating device, which can only indicate an on and off condition. Now, certain systems are able to upwardly adjust sensor alarm threshold automatically to avoid the nuisance alarm resulting from the hostile environments. Now, this type of system will identify the affected detector when the limit of the compensation is reached. Now, analog addressable system. Now we can see node 1, loop 2 device smoke detector only. And you can see how it looks like for the analog. We have the alarm cube that, and we have this the spy cube, the trouble queue, and the monitor queue, and the slide. So all these are the panels. These are panels that you will be able to find in the supply. The conventional versus addressable. Now, initial device circuit, that is the IDC, and the signal line circuit, that is this. So you can see how the conventional fire alarm is done. So for conventional, all of them are done in series, meaning one after the other, one after the other, one after the other. But for the addressable panel, we say that for the addressable panel, they can be tapped. They can be tapped from each other. And then now class B, we had talked about the class B and installation and the appliances. Class A, you can see how they are tapping other additional power. Now bringing it all together. Now when we are now wiring, look at now a typical a fire alarm circuit, how it will look like. Now having a primary source like a 12, this is maybe a battery that is put here, stationary battery, or a second power source is here, and then the transmitter is there, a servicing station. And now we have the initiating device circuits. These are the initiating device circuits. The initiating device circuits are like the manual boxes. We have the smoke detectors and the heat detectors. These are the ones that are able to detect that sound. And now they bring information to the fire alarm control panel. And then now they give the secondary power. These ones are served by the secondary power. And then they give that the control panel now transmit it's called the transmitter supervising station. It transmits this to a remote place where the company is, and then the company is able to respond back and bring the caution to the fire station. So fire alarm system wiring methods. We have wiring methods for the fire alarm system, and some of the wiring methods that we have fire alarm systems are unique. Circuits are either supervised, redundant, or both. Therefore, their wiring methods are a bit different than that of the light power and other limited energy electrical system. So, the installation and use, it's listed on labeled equipment shall be installed and used in accordance with the instruction included in the listing or labeling. Wiring methods and materials. We have the general requirements that are needed for wiring. We have all wiring installations. This article covers wiring methods for wiring installations unless modified by other articles. So we are going to look at the methods. We have another one called the voltage drop. This equipment shall be designed so that it is capable of performing its intended function under the following condition. That is, at 85% and at 110% of the nameplate, that is primary, main, and secondary standby input voltage. So this is supposed to serve it at 85% and at 101%. And then at the ambient temperature, it should be that, and at the relative humidity should be at 85% and an ambient temperature of 65 degrees Fahrenheit. So circuit fundamentals. What are the fundamentals of the circuit? When you want to do the wiring of the circuits, what are the fundamentals? Fundamentals means the basic things. So we need the control panel, we need the source, we need the load. The control panel is the source that gives the power, that powers the circuit, and we have the circuit conductors, and we have the load being like now the transmitters and that, and then we have, I need to see this, I cannot see it well. We have the end of line resistor. We have the end of line resistor. So under the voltage drop, we have is a function of current and resistance. So the resistance is a function of the conductor length and size. We have the types of cables that can be able to install. So a 10 millimeter square with other DC resistance of ohms of about 1,000 over 1,000, that is 1.2. For the 12 millimeter square has 1.98, 14 has 3.07. These are standards that you'll be able to get in the farm. Farms that do this work normally have standards. So we have end of line method. End of line method here is we have the total circuit length that is equals to the distance times 2. That means that if the circuit length will be the distance times 2, because we'll have the positive and the negative. That is the method, another method of installation. And then the devices that we use, we need a smoke, a detector, the heat, flame, gas, and water flow manuals. Then we need boxes, a single cell action, double action, and supervisory signal. We have a valve position, and then we have air pressure, fire pump, addressable modules, and we have the monitor input, and then the SO output relay. The heat sensing and fire detectors, you can see how they look like in the picture. These are now the heat sensing and fire detectors. They can be able to sense heat. So you can see another one. They are installed with sensors called the infrared. Infrared are the sensors that can be able to detect heat change or temperature change. So you can see there, these are a variety of these kinds of the detectors. So the smoke detectors are here. You can see how they look like. Sometimes you will be called to these projects and you'll be told to do the smoke detectors installation. So you should be at least be having a clue. Don't just say that I don't know how to install. Just say you know, and you will try them out, because you can see now I've already told you the procedures and the things needed, and even the procedure of installation. We have the radiant energy sensing fire detectors. You can see them there. These are the radiant energy. We have the spark detecting, can eliminate the early cases of fire or dust explosions. And you can see the way they look like. And then we have the gas detection. These ones are able to detect any gas leakage so that it can be sorted before it causes a disaster. We have the manually actuated alarm initiating devices. These are the alarm initiating devices. Like they are now like the ones that trigger after the smoke detector has sensed the smoke. It brings information to these devices, and they are able to initiate to make sure that the sounders are able to sound an alarm. Now, the manual actuated alarm initiating devices, each manual fire alarm box shall be securely mounted. The operable part of each manual fire alarm box shall not be not less than 42 and not more than 48 in above a flooded level. Then the manual fire alarm box shall be installed so that they are conspicuous, unobstructed, and accessible. Now look at the way they look like now. In case of fire, lift over the cover. These are now the, the ones that are able to be able to bring a trigger to maybe make an alarm. Fire extinguisher electronic monitoring device. You have a device here that monitors this fire extinguisher, meaning in case of a fire, it will automatically open this, pull the trigger, and it will be able to start putting off the fire. Then supervisory signal initiating devices. You can see these ones are manually operated. They are pulled off so that they can start. These are called the hose rails. They are able to supply they can be able to put off fire using maybe by supplying some water. Yes, salad. Huh? Salad.
Yes.
Sema.
Hapana, kuna mtoto ananisumbua hapa, amechukuliwa.
Sawa, mute mic bus. Okay, we proceed. Notification appliances, you can see here, these are now the ones that are able. Now you can see this one is like the alarms or the sounders that are normally installed. I think you have seen these things in some of the buildings. When you walk into the buildings, like for example, the commercial buildings, and these buildings that are the schools, institutions, you will see these kinds of things. So they are used for fire alert. Now we have a public module audible requirements. To ensure the audible public module signals are clearly heard, and they shall be 15 decibel above the average ambient and 5 decibel above the minimum, having a duration of at least 60 seconds. So whichever is greater in the area required to be serviced by the system or the weighted scale, that is the dBA. And we have the average ambient sound level. You can see here for business occupations, these are a set of sounds that are there for the sounders to be able to sound the alarm. Yes, Ibrahim. Hello. If you're not commenting, please just mute your mic. If you're not saying anything, just mute your mic so that we cannot continue getting disturbances. Ibrahim. They have already muted you. So let us proceed. And I've said the sound that is produced is normally measured in decibels. And we have the education occupations, they use like 45 decibels. We have the industrial occupations like 80 decibels, institutional occupations like 50, mercantile occupations, occupancies like 40, piers, water surrounded structures like 40, places of assembly 50, residential occupancies like 35. These are the quantity that is able to measure the sound, or the sound that can be alerted or that can come out, can be able to be emitted to the environment. Sleeping area requirements. Now, where audible appliances provide a signal for sleeping areas, they shall have a sound level of at least 15 decibel above the average ambient sound level, or 5 decibel above the maximum sound level, having a duration of at least 60 seconds, or a sound level of at least 75 decibel, whichever is greater, measured at the pillow or on a weighted scale. So where people are sleeping, because as when the sound is too low, it might be a problem for them to be able to hear. So it has to be loud enough to be able to wake up these people very fast so that they can rescue themselves in case of a fire outbreak. This is normally installed in places like hotels where we have restrooms or guest rooms. And then we have the visible notification appliance. We had talked about them. Visible signal requirements. And now the visible notification appliances shall be installed in accordance with the table that we saw using the following. A single visible notification appliance. The two groups of visible notification appliances where these appliances of each group are synchronized. That is visualization in the same room or adjacent space within a field of the view. So this should include synchronization of the strobes operated by separate systems. More than two visible notification appliances or groups are synchronized appliances in the same room or adjacent within the field view, the flash synchronization. So synchronization means they have to work hand in hand with the audio systems. So the visual signal requirements are wall-mounted appliance location at the entire length, that is 80 inch to 96 inch above the finished floor, except the sleeping areas. We have the ceiling-mounted appliances like now the sounders, the heat detectors, the smoke detectors are ceiling-mounted appliances with 30 inches. Then the sleeping areas, we have the 177 within the ceiling. So those are the requirements of doing the visual appliances. These are the things that you can be able to see easily. Textual audible appliances. These are the ones that can be able to send text. We said that when the sounders make the noise, they can be able again to send the wireless instruments or appliances are able to send text to the fire control stations so that they can be able to trace the place. So the textual audible appliances as they look like. The annotator formats, you can see this one, I can give the directory. They can even give the direction of where the building is and the exact room that is on fire. Like we said, the heat detectors are able to even detect and give the exact place that the fire has broken out. Emergency communication system. One-way emergency communication system. We have also distributed recipient mass notification system. We have in-building fire emergency, that is voice alarm communication system. We have in-building mass notification system. We have wide area mass notification system, a two-way emergency notification communication system. For the system employing a relocation or partial evacuation, a level 2 or level 3 pathway availability shall be required. Pathway surveyability level 2 shall consist of one or more of the following. That is a 2-hour fire-rated circuit integrity cable, a 2-hour fire-rated cable system, electrical circuit provision protective system, a 2-hour fire-rated enclosure or protected area, a 2-hour performance alternatives, and approved by the authority having jurisdiction. So the pathway surveillance level 3 shall consist of the pathways in buildings that are fully protected by an automatic sprinkler system in accordance with the NFPA. A 2-hour fire-rated circuit integrity, a 2-hour fire-rated cable system, a 2-hour fire-rated enclosure or protected area, a 2-hour performance alternatives are approved by the authority having jurisdiction. A balanced fire protection, we have an alarm and detection to provide occupants early warning, sprinkler system to suppress and extinguish, fire and smoke barriers to provide tenability. Emergency control function interface, these are things that you'll be able to see. We have the elevator recall and firefighters We have elevator shutdown. We have fire service access elevators, occupants evacuation elevators. We have the HVAC system. We have the door and shutter release. We have the electricity locked doors. Electrically locked doors will be opened. Exit marking audible notification assistance. So all those things are things that have to be enabled in case of a fire outbreak. Now the functions and interfaces, they maintain path of ingress, maintain areas of refuge, provide clear approach for firefighters, minimize fire and smoke damage. So elevators, I recall, now you can see now like these people, these have been caught in a fire and they are in the elevator and they're like, what can we do? They don't know what they can do. They're asking for help. You can see people are, all of them have their mouth open looking for help. So in such a situation, elevators have to, when sprinklers are installed in elevators, pits install automatic fire detection to initiate the sprinkler, that is the elevator recall. And where sprinklers are located above the lowest level of recall, or now locate the fire detection device and the hoistway top. Then where sprinklers are located at the bottom of the hoistway pit, that is the fire devices shall be installed in the pit, and the outputs of the elevator controller shall comply with that standard. Okay, um, I think this handout is almost done. Now, elevators recall for firefighters. A smoke detector shall not be installed in a single elevator hostway unless they are installed to activate the elevator hostway smoke relief equipment. Ambient conditions prohibit installation automatic smoke detection. Other automatic fire detection shall be permitted. Smoke control systems. We have the smoke control as required by the building code is intended to limit the spread of smoke, direct the smoke out of the building. Natural control methods are now the use of windows, panels, and or hatches so that smoke will flow directly to the outside. We have the mechanical, the use of building that the HCV equipment to exhaust smoke and bring out to air. Now, smoke detectors for control of smoke spread classifications. We have smoke detectors installed and used to prevent smoke spread by including control fans, dampers, doors, and other equipment that shall be classified in the following manner. So, area detectors are installed in the related smoke components. The detectors that are installed in the air duct system. We have independent smoke detection that is installed in the related smoke masks that are able to detect smoke. The smoke detectors are controlled smoke spread. They are the devices that are able to control. So the moment they detect the smoke, they control the spread of smoke by either fanning it out to the environment or channeling it to a certain duct that is able to spread the smoke. And we realize that when there is a fire outbreak, some of the dangerous things that are detected of the dangerous things that make somebody to die faster in the presence of smoke, because smoke will not allow the circulation of pure breathing oxygen, or so, and it will make it impossible for the people trapped inside the fire to breathe well, and hence will die faster from the smoke even before they get the burns. So the smoke detectors are very important because they are used to pump out the smoke. They used to pump out the smoke from the room. Okay. Emergency control functions. Emergency control functions interface devices shall be located within 3 feet of their component controlling the emergency control function. Now exit making audible notification system. Different systems that are used to give notifications or to notify the occupants that there is danger around. Now we have questions here. What NFPA chapter governs commercial fire alarm system. We will answer this at your own time. Yes, Edgar. Watu wanajipata wame unmute.
Madam.
Edgar. Yes.
Yes.
Nimeona umeunmute. You wanted to ask a question?
Madam, huku kelele ni mingi hata sikusikii.
Kelele iko kwako ama wapi?
Yani on your background.
Are you sure?
Like zina vitu zina vibrate.
Can everybody confirm that? Because I've not noticed that.
Nianzie hii last slide. Nianzie tu hii last slide.
Haikukuwa kutoka hapo mwanzo.
Inafanya hivi.
Hivyo sasa bado inaendelea?
Sasa imetulia.
So labda is because nilikuwa na move microphone yangu. So slide gani ya mwisho hii?
Enda mbele kiasi.
Hiyo? Hapo. Tuanzie hapo. Hapo nilikuwa nawaambia, I was telling you about the smoke detectors for the control panel. These smoke detectors are able to help the removing of smoke. And we said that smoke is the one that causes people to die very fast, because the presence of smoke means there's no the people cannot breathe well. So you breathe smoke and it chokes you, and it denies you air to breathe. So the smoke detectors have come in to be able to pump out the smoke. And we said there are several formats of these smoke detectors that are able to pump out smoke, like the smoke ducts, the fans that are able to pump the smoke out to the environment or to normal air and pump in fresh air so that people can be evacuated in case of emergency. And then the emergency control function interface, we say that the device that shall be located within 3 feet of the component controlling the emergency control function. So you can see the Audible notification system there. I said the Audible notification system is the one that is able to notify people where people can exit. So the moment there's this fire, as much as the sounders are warning an alarm, the notification systems are also telling people that this is the exit, this is the exit. They tell people about the exit points. Sometimes when there's fire breakout, people get confused and they cannot even get their way out. So these notification systems will be able to inform people that this is where you can use your exit or you can get your way out. And I said these are some of the questions that we discuss at your own time. Like now, the standards of smoke control systems and the fire protection and the rules that govern. So in conclusion, a building code does not allow a logo, chimney, or a Lincoln login cabin. These are just cartoons that are there. So I'm bringing out another presentation. We said we are classifying these fire systems into zones. We have around 17 minutes. Remember, when Salad was in, I told him that today we are going to have a moderation meeting. From 11. So I told you that I wanted to cover the first 1 hour for this electrical installation, and we use the next 1 hour for workshop and organization. That is for the big blue button. But for discussions, they just remain the way they are. Once we finish, you can be able to join the discussion in the electrical installation. And again, you can join the discussion in the workshop organization. But for the big blue button, I want us to just have continuous 1 hour for each of the units. So we are almost done with this one. And then I'll give you a break like for 5 minutes. And then we come back to workshop organization and also take another 1 hour so that we can cover what we are supposed to cover from 11. At 11, we are going to have a moderation meeting, and I don't know when it will end. That is why we have to make that local arrangement. I hope you have loaded your bundles well so that you don't get cut off. Edgar, you are the one who is more prone to that. I hope you have enough bundles.
Yeah, I have.
Oh, okay. So we are almost done with the installation, and I'm almost winding up. So I want us to discuss about the zones. How do we distribute the zones of the fire alarm when we are installing the fire alarm or panels? So before we do that, we have important notes here. These equipments must only be installed and maintained by a suitable, skilled or technician, a competent competent person. And remember, in our first slide, we discussed about a competent person. We said that a competent person, this is a person who is experienced and who is skilled enough to be able to do the fire circuit or fire alarm circuit installation. And this equipment is a piece of class 1 equipment and must be earthed. So it has to be earthed. So any fire alarm circuit installation has to include an earthing. To meet the requirements for the BS standards, a manual of points must still operate when any detectors are removed from their bases. So this is mandatory whether or not the detectors have locking or shorting devices. So to comply with this directive, either a manual call points must be wired before the detectors, incurring extra installation expenses, or a detector based with diodes fitted must be used to ensure continuity when the detectors and call points are mixed. So the MFP range of panels will operate in this way and will give a distinct fault indication when a head is removed. So if you connect the battery, if you connect the battery leads, if you connect the battery leads in reverse, you will blow the battery fuse and you risk damaging the panel. So this fault factory detectable and you will be chargeable for the repair. So if the battery or power supply fault light comes on whilst the mains are on, lit is lit or is on or is lit, then it usually means that the battery is either discharged or faulty. So those are some of the basic instructions for that. So guides for fire alarm design. So before we can do the installation or the wiring installation, we have to do the design. So we have to design the control panels. The fire control panel is must be sited internally in an area where it is readily accessible by the staff on duty and the fire brigade, and should be clean and dry, and should take into account any likelihood of tampering or vandalism. So the indicators to be clearly seen, and then the internal sounders to be heard. That is, the full details are found in that. Also, we have talked about that anyway. And then the sounders, all sounders must be polarized. That is, unpolarized sounders will show a sounder fault, meaning they have to be polarized. So the most common sounders are bells and electronic sounders. We have the motorized sirens. Let me just zoom out a bit so that we can able to see. The motorized siren must not be used on these panels, so the same type of sounders must be used throughout the building, and it must be distinctive so that the sound associated with the fire alarm is easily recognized. The minimum sound level is 65 decibel to 5 decibel above the background noise, likely to persist for long than 30 minutes. So the fire alarm must be audible in every part of the building. So for sleeping accommodation, the sound level should be 75 decibel. I think we had talked about that. And at the bed head, if sleeping people with normal hearing are to be awakened. 4 sound circuits are provided. Not all need to be used, but at least one circuit should be connected with at least one sounder on each. Sounders should be wired in appropriately equal numbers on each circuit, meaning each circuit needs to have at least one sounder. Now, manual call points. The manual call points should be sited on all exit routes, especially on landings and staircases and final exit doors, with a minimum distance, from the any place of the building to a call point of at least 30 meters. So they should ideally be sited 1.5 meters above the floor in the conspicuous and easily reached position. So the manual call points are they are like now the switches or the buttons that are normally pressed. You realize that in hallways now, like for example in institutions, like even in schools, the hallways, you will see these call points, and some of them will be noted that in case of fire, break this glass. So when you break the glass, so it will ignite the sounders, or to be able to make the noise or alert people. So those are the call points. The call points are the ones that are able to initiate the process of sending a signal to the right channels. So important is that many call points are now supplied with a resistor already fitted. This can be determined by measuring with a good quality ohmmeter. So the call point should normally measure open circuit and 470 to 680 ohms when activated. So if the call points are not of this type, then a series of resistors must be connected in series with the call points in order to ensure that an alarm condition will occur. So you can see the circuits. Now, normal position and activated position, how the resistors are. In normal position, the call point resistor is there, and the way it is connected, and the looping, the way it is looped out, and in the activated condition, meaning when it is activated, the way it looks like. So when it is normal, meaning it will be on the normal point. You can see the normally open, the normally closed. And when it is activated, meaning it now goes, it is like a switch. It now goes to the normally closed, and it can be able to sound the alarm, and it can activate and trigger any emergencies that is needed. Note, the resistors are not included in the panel but are available from electronic component suppliers. So failure to include this resistor will cause the panel to show a short circuit fault indication when the call point is operated. So for those who will find themselves installing these things, you should know that you have to include a resistor in the manual call point. So this also applies to any other form of switch used to trigger the detector circuits. This panel will work with resistance values from at least 470 to 680 ohms fitted. So the resistor must be rated a half watt. You can see that. We have smoke and heat detectors. We talked about them. Smoke and heat detectors. Up to 20 heat or smoke detectors can be fitted on each zone. So smoke detectors, there are two types of smoke detectors, ionization and optional. So ionization are generally quickest and at detecting a clean burning fire. The optional are quickest at detecting the smoldering fire. The smoldering fire is one that is starting. So neither one is better than the other in all circumstances. Some fire authorities will only allow one kind, and you should check with the fire officer. So do not cite smoke detectors in draft. Cite for detectors depending on many factors. That is, according to the BS standard, that is the 5839. And if you want to know the IEE regulations on the fire alarm detectors, or even the call point, the callers and sounders, you can get it in the BS standard, that is the 5839. You will be asked this in your exams, that which state the BS standards or the IEE regulation BS standard for fire alarm. So you should be able to know which one will give you that detection. So it states that fire detection and alarm systems for building should be consulted for full details of spacing. That is the dust, smoke, steam, water vapor, and condensation will affect the detectors. So causing of false alarm and the need for frequent cleaning. So under these conditions, the use of heat detectors should be considered as below. Note that building work causes adverse conditions. If possible, Remove all detectors from site until work is completed to avoid contamination. The heat detectors, these are used in places where smoke detectors are not practical, such as kitchens. You cannot use smoke detectors in kitchens because kitchens normally have smoke, and boiler rooms, which normally has smoke. So instead, we use heat detectors that are able to detect a change in level of heat. So there are two kinds. We have the fixed temperature rate and the rate of rise. So the fixed temperature detectors are used when sudden rise in temperature would cause alarms are common, and such as in kitchens. And the rate in rise detectors are used elsewhere as they generally respond faster than fixed temperature detectors. We have batteries that are used to power these appliances. For emergency standby power supply, two good quality 2 volts sealed lead acid batteries are connected in series should be used. They should be of a type they have at least 4 years life under normal conditions. So the capacity of the batteries used will depend on the required standby time. So the battery condition, that is details, see installation. Always dispose of the use of battery according to the battery manufacturing instructions. Information. This range of panels features a sophisticated battery monitoring circuit, which instead of monitoring the current being passed through the batteries, actually detect their condition. Consequently, a discharged battery or one with deteriorating cells will slow a battery power supply fault. Test will run a new fully charged battery. Now we have the cable types. The cable types that are used, we have the sounder. Sounders must be wired in cable complying with, for example, the standard, the BS standard 6207, which are the MICC or the PRAO. And then detectors may be wired in cables that comply with, for example, the 6004, that is the PVC, or the 6207. Ensure you comply with the BS standards. The common BS standards for the fire alarm is the 5839, which is very important regarding the sighting installation, and the choice of cables. Note for the overall design is that decide on the position of all parts and mark the plans accordingly. So get the fire officer to check them to ensure any special requirements, and he may have to comply with his or his right refuse the certificate. Note that fully complying with this standard, manual call point must still operate when any detectors are removed. So this can be accommodated by wiring call points first or by using detectors based with continuity diodes. Note that never spur off any detector or sounder cable run, as the spur wiring will not be monitored correctly. So we don't need a spur wiring. So the installations are here. The typical zones are loop circuits are here. You can see the panel, terminal, the call points, the detectors are here, and then the call points and then detectors. And we say the call points are used for the communication or detection. And then we have the red and black, the end of line devices. So the zoom loop. The zoom loop circuit call points wires before detectors, a base diode in not needed. If the detector removed and then the open circuit false warning given, that is the panel zone, terminals, call point, detector, you can see how they are wiring. And we have these are zoom loop, these are when they are in zone. And then 3-wire loop wiring, you can now see. You know, you'll be given these things, you can be given in your practicals. There's a time that people were not given the electric bells, but they were given the fire alarm detectors. So you should be able to know how the circuit goes. You can see now the panel is here, the call point is there, the detectors. We said the detectors can be the heat detectors. And then we have the sounders. The sounders are normally connected in parallel. We said each circuit must have a sounder. So we have a call point there, the detector, and the end line. You can see. So this is now the process of how to fix the cables and run the cables. and I think we don't have enough time. So unmute your mic so that we can agree on something. Edgar.
Madam.
Our time is already up, but we have not finished this handout. What do you think? Can I leave you to finish it on your own?
Yeah, utaprint tumalize by your own.
Huh?
Yes.
Yeah.
Salad, si hapo ni sawa?
Yes.
It is a very important handout. Mtaisoma because next week tuna meet, nataka tusome juu ya safety in installing of these fire alarms. I don't want us to come back here. So mkisoma, it is a very good handout and it will help you in the installation of the fire detectors. You can see. So I want us to have a break of at least 5 minutes so that I can do I can change the settings in the big blue button for the timing of workshop, organization, and then to ingie. Unless there's a question, I will want us to go for a break. Swali?
Hasina swali.
Wewe hauna swali. Na mwingine? Humphrey?
Yes.
Humphrey, uko na swali? Oh, hata wewe Salad uko sawa?
Yes.
Sawa. Sasa nataka kuwapea a break of 5 minutes vile nimewaambia. So at exactly 9, can it be 9:17?
9:20.
Nataka tu kuchange settings za warm. Ama 5 minutes ni kidogo.
Tupe 9:20 ama 9:30 hapo.
9:20.
Tukuje 9:20. Sawa, wacha tukuje 9:20 tuanze hiyo workshop and please come in, kujeni mapema so that tumalize. Nimewaambia ni nini inafanyika.
Yes.
Alafu nani alien ati sijakwambia Edgar na nimeongea saa hii. Alfred. Nimesema tunataka kukuwa na a class ya workshop in the next